Cool. Welcome to the Rust 1.97 changelog discussion with Pete, Cameron, and me, Chris. Rust publishes a new stable release every 6 weeks, and this is what's new and what you should care about, and maybe a little bit of context around that. So let's just get right into it with symbol mangling. V0, why V0 symbol mangling? Like, why is there a V0 instead of, a V1? Did we not do symbol mangling before? Cameron, I think you have some thoughts on this, right?
Yeah, so symbol mangling, this kind of stuff is kind of interesting in anyways. Like, why we have to mangle things is just kind of interesting. What I thought was pretty interesting about this was that if you read the Reddit comments on the release, there's a user that points out that this was actually like a really long time in the making, because once we break how things are mangled now, like here, that means that like third-party tools like GDB would also break. And so we're fixing something that would make Rust better, but then in turn would have broken everyone's tool chains for everything else. And so the way I'm reading this comment, and I haven't validated any of it, verified any of it, but the user is suggesting that like the Rust team reached out to all these third-party projects and was like, hey, we're about to do this thing. It makes sense for all of us to work together on this thing and to update things and to make sure that it works together so that we're not making everyone really angry. And I just think that's kind of cool. That I think that kind of is something that I know other teams do it, but I think Rust does really well. It's like that whole thing where like anytime when we run Crater, and Crater will open a PR that says, hey, there's something happening in this new release of Rust that's not out yet, and it won't be out for a while, but your stuff might break. And I just think that's like really cool that Rust is super proactive that way. And I mean, you only get to do that because Rust is a newer language that doesn't have all that baggage that naturally came about.
And Crater being this tool that the Rust project uses to compile against all of basically crates.io. Not technically all of it, I don't think, but a vast majority of it, or a sub-select.
It's about 60 to 70% of what's on crates.io. It's actually not just what's on crates.io. I believe it's all publicly available Rust code. It's not just, there are some other repositories that we have access to, but it's only about 60 or 70% because there's a lot of legacy stuff that just wouldn't, that maybe never compiled. And so we just have that on an ignore list. And so there's a significant amount of hello worlds out there that we don't care about.
I'm sure I have some code that is never compiled sitting on my laptop somewhere.
Yeah. It may or may not be my work projects right now. I don't know.
Cool. I think next up we have some cargo support for denying warnings. This is a replacement for Rust flags. Rust flags being a thing that is, somewhat combative with like rebuilding projects. If you change Rust flags, you have to rebuild a lot more stuff than you otherwise would have if you weren't changing Rust flags. And in CI, a lot of people do this thing where they like block on warnings, right? So in development, you want warnings to be warnings because you want your program to run. But in CI, you don't want those warnings to like ship to production. So different levels of configuration. And it seems that Cargo now has support for a new environment variable that is not Rust flags called cargo build warnings to deny the warnings. So now you don't need to do like cargo toml build whatever config. You can just set this environment variable, which is pretty cool. I think there's something else here about keep going.
Yeah, this was the one thing I thought, and I feel like an idiot not knowing that this flag existed, but I didn't know that this -- keep -- going flag existed, which in theory, I mean, it hasn't really broken anything or really changed anything, and it just made my CI workflow significantly longer and slower than it needed to be, which is pretty funny in a lot of different ways, but...
Yeah, everybody wants longer and slower CI, right? That's what the people are clamoring for. Speaking of compiler level stuff, linker output is no longer hidden by default. Pete, maybe you want to like cover what is a linker? Why do I care? And what would it output that I want to look at all, other than really confusing errors?
Yeah, right. So there's sort of the perennial story, maybe around Rust, which is like compile times. We should get compile times down. We will not talk about compile times today, but as a part of compile times and compiler stuff happening and you getting an end binary that you can use, there's compilation, but there's also a link step, and so there's some cool work going on elsewhere that I'll kind of name drop, like the wild linker. That's really cool. That's kind of getting shaped up and is supposed to be a little bit, or maybe significantly in some cases, faster and really cool. But with regards to this item here, we see that you get a little bit more information out of the linker messages. So you are able to take a look and see what's available here. You're able to do some configuration of this, it looks like. So you can have in your cargo.toml an entry there that says linker messages equals allow. You can silence the warning, I guess, if you're able to do this. Again, I'm sort of looking at this and thinking, more information is probably better than less if you're trying to debug something, especially if it's maybe complicated where you're having to deal with like FFI, so foreign function interface, having to deal with interop between, say, C++ and Rust code.
Yeah, I think more information is always better. Well, maybe not always better. Seems some pretty verbose logs. But
so what are we at? We're at,
especially
we're
when
at we should CI should be super long and logs should be verbose and difficult to parse. Okay, cool. All right.
Cool. We're on a good path here. Cool. I think that brings us to some new stuff. There's this consider result T uninhabited or control flow uninhabited T to be equivalent to the T type for the must use lint. Now must use marks a value that has to be used. So like the way that people would normally see this in Rust is the result type. If you call a function, it returns a result. You are going to get a warning if you don't handle that in some way, because you could miss an error, basically, if you don't handle this value. So you must use it, right? But there's something else here about uninhabited. What's uninhabited, Pete? Like, this refers to non-constructible types, but why would I want a type that I can't even make?
Yeah, sometimes it's helpful to be able to specify this in your code, particularly if you want to make it clear that something can never happen. You want to make it crystal clear in the code that something should not ever occur. There's also some instances around FFI. So speaking of FFI, keeps coming up in our conversation, but there's instances when you're interacting across FFI where you want to ensure that certain states are really never entered, and you want to make sure that's clear on the Rust side of this FFI or this interop that's occurring.
Yeah, you said never happens. There's a never type in Rust.
Indeed.
What
is there one
type?
in Rust yet?
Well, it's a good question.
Yeah, I mean, there is if you're running the right compiler version. So, and it's a nightly only feature currently from the looks of things. But there are instances where you can sort of replicate it using this stable thing. There's an enum. It exists in core convert. It's called infallible. It's literally just an empty enum, but you can use it in places where you would either on nightly use the never type or in the future would want to use the never type when it's stabilized. And there are plans listed in the docs which say, hey, in the future, we do plan to, in fact, simply alias from infallible over to the never type once it's stabilized, and then eventually deprecate infallible. So there are some sort of future looking plans once this is stabilized.
And it sounds like there's some kind of like evolution process going on here, in addition to some unstable flags and stuff like that, which is pretty cool.
Yeah, definitely.
If you want to learn more about the never type and what's upcoming, there was a talk at RustWeek by Waffle,
Right. Yep.
I believe.
That's
and
right.
I will make sure that we put a link to that video in a show note or something like that, if you're interested in learning more about the never type stuff that we're talking about.
Yeah, Waffle's talks are always great.
Yeah, so speaking of like evolution, yeah, the interesting thing to see when I was looking back through this and kind of doing a little tracing back the steps of how this occurred and how the teams worked together, it looked like the language team and the compiler team wanted to be able to land this feature. To Cameron's point that he raised earlier of sort of making sure everyone's on the same page and collaborating. This was a case where those two teams, it looked like the language team, the compiler team, reached out to the Clippy team and said, hey, like there's a new thing that we want to do. It involves this uninhabited type. We want to enable this in the compiler, but could we have in Clippy a couple of versions ahead, something landed which will sort of make users more used to this idea that this will be coming? Yeah, so looking through this, it looks like that landed in 195 so that users could get a heads up before the compiler change actually landed in 197. So really cool to see that kind of like cross-team collaboration happening and enabling that, end users feel like they're supported.
Yeah, I feel like that's one of the reasons that Rust feels like a very stable language. Like the breaking change or whatever didn't land, and it surprised everybody. There's like a Clippy lint, and then preparing to move ahead of compile changes. So you've got a couple of versions in which you can sort of discover that something is coming and then actually change it and then be prepared when it actually does land.
Yeah, for sure.
Next up, do either of you tend to use pub in, your main.rs, your executable crates?
I actually feel like you have to use it in one of the RTOSs. And when you're doing some stuff with WASM, I feel like it's actually required, or maybe it was at one point. I haven't touched that stuff in quite a while. I used to do some embedded work, and Embassy. I think it's Embassy is the one. And I might be wrong on which one it is, so don't shoot me. But one of them required pub for some of that. And there was another spot where your main was required. I don't remember what it was even, but like it was all stuff when I was doing WASM and embedded kind of any non-stid, like odd niche things.
Yeah, like reasonably esoteric stuff, not like,
Right.
I'm going to write a main.rs and run an executable, which is important because using pub in binaries for function items and things like that affects the ability of the Rust compiler to like detect and eliminate dead code. So in Rust 1.95, if you use pub crate, that can be detected as dead code because you can't use a function from that executable. But if it was just pub for whatever reason, for one of these other use cases or something like that, that wouldn't get picked up. And now we have this new dead code pub in binary lint that will basically treat a raw pub item as a pub crate and raise that lint for you to actually know that you are sort of including things that can't even be used ever.
Here's extra, right? So it's just a way of trying to prevent extra cruft maybe from creeping in, right? Or things that, there's really no reason for them to be in there, I guess, based on the, how you're setting up the binary.
Yeah. Everyone likes smaller binaries, right? Speaking of alternate architectures, Rust 1.97 partially stabilizes the LoongArch, so the arch the long way, target features. Now, I'm not super familiar with this. I don't know how much experience you both have with this. This is apparently RISC-like, but not actually RISC-V. And my understanding of the features here is that you can now basically feature gate based on whether certain target features are available using the target feature attribute macro for like conditional compilation and stuff like that, which is very cool.
I will say that I do not have experience with this too much, although there are some folks that I know are interested in RISC-V, and I'm talking with some of those folks, but that's, as you said, unrelated. So yeah, I don't know about in this case.
I was looking up to see if the name was actually like just multiple O's because of long cat, like that old internet name. And it turns out,
I don't think it is.
It's not. I just want to make it very public that that's not the case. I ask the tough questions so you don't have to. It's actually LoongArch is it looks like it's actually developed by a Chinese company named LoongSan. And so that would make sense that it's LoongArch after the name of the company that started it, and not an old internet meme, disappointingly.
It is not named after the fantastic childhood cartoon Cacti.
Deep pull. Yeah.
All right. So what's next?
So we've got this other config. So config target has atomic equal alignment. There's a couple things in there that people might not be familiar with. Does somebody want to sort of cover what atomics are in the first place, or what alignment is?
Pete, I think you'd be fantastic at this.
Thank you for voluntolding me. All right. So basically there's this need oftentimes in our modern world of running concurrent parallel code. I always get confused on which is which, and please put in the comments which is which so I'm correct. But in any case, the point is though that when you're running code that might be on different threads, or there might be a thread pool where tasks are getting pulled off and code is being executed. It's very useful to have these types that are atomic, meaning that it's possible for us to store and load things from them in a way that will be seen safely across different threads. And so this is some very useful aspect that is right in I believe it's in the core library. Yeah, it's in the core library. So those are atomics. awesome book by Mara Bos that I used around 2 years ago to implement some stuff in an open source project. It was excellent. So yeah, if you're interested in learning more about atomics, locks, that sort of stuff, could definitely recommend Mara's book.
Mara's book is fantastic. I learned a lot of what I know about them from that book as well.
So now that we know what atomics are, what does this config flag actually enable?
Yeah, so the config flag, these atomics are basically like 8-bit, 16-bit, 32-bit, like integer values, more or less. So what is the actual alignment of those atomic values compared to actual like numeric values of the same types? And this is a config flag to detect the alignment, which I guess we didn't explain. So Pete, do you want to cover like what alignment is?
Sure. Oh, okay. Yeah. Thank you for being the second one Devon told me. So yeah. So alignment is a concept that comes up in computer architectures, and they can vary between different computer architectures around how we set up the particular bits and bytes that go into representing something. And so, for example, I won't say any particular architectures because I can't pull any off the top of my head, but on, say, certain architectures, you may want to align things along 4 bytes or 8 bytes or something like this so that you benefit from performance in the processor and the CPU when you're running data, when you're running computations on it. So that's what alignment is in general, but depending on which architecture that you're running on, that can vary. And so I guess that Chris has some impact here on this particular thing that you can configure. Is that correct?
Yeah, the config does, yes.
Yeah.
Speaking of like which platforms alignment is relevant for, it can be relevant for GPU code. Not that everybody's running Rust code on GPUs, but alignment is definitely like a concern when you're passing data for certain platforms.
I think it gets important with SIMD stuff also, right? Like,
I think you are right. Yeah, alignment does matter when you start talking about SIMD and like David Wood. I think he gave a talk at, was it Rust Nation UK about various things related to sizedness of different things and SIMD and alignment. So if you're interested more in those topics, you could check out his talk, I suppose, for kind of cool stuff that's cooking in the compiler related to that.
And just to be clear to anyone that actually hears this stuff and goes, what the heck are they talking about? We don't really know what we're talking about. So don't feel bad if you don't know what you're talking about. But also, like, combined, the three of us probably have been working in Rust for as long as pretty much anybody else. And this is stuff that we don't even think about most days. Like, I think about this stuff once or twice a year, let alone, like, it's not that important. It's extremely important that someone is worrying about it, but it's not important that you need to like go read 12 books if you don't understand the stuff.
Yeah, I think especially in the case of like SIMD or like GPU alignment or something like that, like it matters if you're doing very specific things. And like even sometimes if those things apply to your program, they might not actually be better than doing it other ways, especially in the case of like SIMD, for example. So, it's very use case specific.
You'll know when you need to learn the stuff.
It will be obvious.
Yeah, it'll be really, exactly.
Speaking about platforms that support alignment, GPUs in general, but NVPTX64, which is an NVIDIA CUDA architecture for a Rust target, that is, which I believe is somewhat related to the Rust GPU work, but I'm not 100% sure. There's some support and some tiering and stuff like that for these platforms and targets. And the support for some things on some older versions of this NVIDIA CUDA platform target have been dropped for old instruction architectures, which, is very, very niche. But I was thinking that maybe Cameron, you can tell us like what's tier 2? Like what is tier 1? Like why are there tiers?
So Rust has a bunch of guarantees. So like one of the guarantees is that, it's like Rust will never, will probably never have a Rust 2.0, right? Because Rust promises that it'll always be forward compatible, or it'll always be, I said that backwards probably, but the compiler today will always be able to compile something from yesterday unless there was like some crazy weird thing. It's happened before, but very, very rare. And so when things are tested in Rust. The way that they make these guarantees is they test against a whole bunch of different things. And there's probably, I don't know, there's at least dozens, if not more architectures. There's probably hundreds of different architectures in the history of computers. And it doesn't make sense for us we don't have the capacity to test against everything. And it doesn't make sense because most of these things are probably not used all that much anymore. And so the things that Rust tests every single, I don't know if it's every single build against, but every single, at least every single release, even not even just releases, but nightlies and everything against is always tier 1. Tier 1, everything gets tested and it never breaks. Then tier 2 is where like it doesn't get tested every single time. It gets tested, and I'm going to make up some stuff because it's to just like if everything gets tested on tier 1, if it got tested 10 times a day, maybe the stuff on tier 2 only gets tested every other day, kind of that kind of thing. Like it just doesn't get tested as often because it's not necessarily worth the entire team slowing down the development, but then also burning CPU and, you know, eventually helping exacerbate the eventual heat death of the universe for every one of these things. And then there's also tier 3, which is even smaller. So like you might like, I think at one point, like there's like some old gaming platforms that were like on a tier 3 or something like that. And like stuff that you're never going to build Rust on a PlayStation 2. Like they're, yeah, like I think the Switch was actually somewhere, and it's like, you're never going to build, or you're probably not going to build. And if you are going to do that, then that means that you can either run those tests yourself because you're familiar enough with that, or you're a company who's making giant video games who can pay for us to spend the time to move that to tier 1 or tier 2. So that's kind of what it is. It's just basically how often and how much effort we put into making sure that nothing breaks. So tier 2, there can be, I believe, some warnings are allowed during releases. And then like tier 3, sometimes we'll just say tier 3 breaks for this release. And I might be off. There might be a tier 4 where that's allowed. I don't quite remember exactly, but tier 1 is the one that Rust proper is tier 1, and x86 is tier 1. Your normal AMDs are tier 1. You know what I mean?
Yeah. You know, hopefully one day I will be able to compile my Rust code for the Nintendo Switch, but until then I have to settle for running code on my Game Boy Advance, which is wonderful and is quite the experience. Cool. So we're getting pretty close to the end of like the changelog related changes, but there is one last thing about Clippy's open code review that they're starting to do. This is super interesting from like an open source perspective, and I do a lot of open source stuff. So basically at RustWeek, there was a talk by Alice about Bevy's open code review and sort of like community contribution systems. She wrote a blog post. That blog post got shared with the Rust project in various channels. The Clippy team has decided to now do or encourage community code review, which is really, really, really cool. And I think is a really powerful way to kind of like upskill people into being able to work on the project. And as we all know, like every open source project has a review bandwidth problem, right? Like what open source project has like too many reviewers and not enough code?
We need some of those over here. Just send them to the Rust project. We will take them. We'll take all of them.
So, I mean, like I could probably just talk about that all day, but like, what do you all think about open code review and like people, when you submit a PR, getting like another one to review in exchange?
So, I mean, it's kind of how Rust works, like the actual core Rust, right? You know, so when someone submits a PR, it's Rust bots or bores or something along those lines. One of the, if you're not familiar with this, there's Rust has like 1 million bots that it automate all of the processes. And they've been that way for a long time. It's pretty wild how much bot stuff has been going on with Rust for that long. Like if I were to submit a PR to the Rust project, this bot will like actually look at the PR and it can tell based on some type of like who should review that code. So say Chris was someone that had touched this piece of code for a lot previously, then maybe it would flag Chris. And if not, it might just, it might randomly grab somebody else. But like it kind of forces someone to be able to have to look at that code, because he at least has to look at it to reassign it to somebody else. And Chris might know that actually this is Pete's purview, but this is kind of along those lines, but it's essentially just like, if you submit a PR, then we recommend that you also review another PR while you're there. I mean, I think that's pretty cool, especially because I feel like, because this is only on Clippy. Clippy is a pretty low stakes. Like, if you review something and you're unsure, like, it's not the end of the world. Clippy is super handy. Clippy is super fantastic. I love Clippy, but it's not rocket science. I mean, it could be, but
speak for yourself, Cameron.
But I like that they're trying to find something, because I see this a lot in open source and a lot in, like especially on Reddit comments and just like social media in general. Everyone loves to complain about everything, and no one ever wants to go like, well, hey, cool. Like, I'm glad that you've been complaining about that for 2 days or 2 years or whatever. Have you ever thought about like proposing a solution? And then there's also like, everyone can complain. And then also like ideas, like proposing solutions are like, everyone has a solution, but who's going to implement it? This is a way to make something actionable, to like, it's pretty simple. It would be kind of interesting if I have some ideas on how to incentivize this and make it even cooler, but then also like, do you really want to gamify frickin' PRs? I don't know, but like encouraging people to review stuff, anything you can do to get more people involved and more eyes on stuff is positive, in my opinion.
Yeah, I think it's working out really, really well for Bevy. People are developing expertise in areas they otherwise wouldn't. Like you were saying, like even if something does feel like rocket science, doing a PR review of the pieces that you feel like you can is also super valuable. For example, taking a PR, running it, being like, it worked on this code, and then saying that as part of a review. You don't have to be like, I know that this is implemented perfectly. You can be like, I ran this on this code. It worked for that. And now the people who need to merge it have significantly more information than they did before.
And one thing just to point out with Bevy, if you're not familiar with the project, Bevy has to be, I would assume, one of the larger, faster moving code bases that is written in Rust, at least. I don't know. I know that my meetup, I do like a what happened this month in Rust every month at my meetup, and I'm not a gamer. I don't write games. I don't do anything in games, but Bevy is always something I have to mention because every release they had 1,000 PRs merged.
Oh, wow.
And I don't even know if I'm exaggerating on that.
Yeah, you are exaggerating.
I don't freaking know. It's an insane.
It's something like 250 contributors. In
oh,
every
I'm so sorry. I was off by like barely. 250 contributors is still a ridiculous amount of contributors it
was 1,185 in the last release. You were right.
Oh, dang.
Okay, thank you.
You were absolutely right. I fact checked.
You know what? I have to drop. I'll see you guys later.
That's it.
Yeah, no, that's exactly what it is. Is just Bevy is just as insanely just like with the old school Rust releases back in the day. They still do it. It's just not as obvious. But like they thank all the contributors, and one of the things is they call out first time contributors, and there's always a fairly significant number of that number of contributors is actually first timers. And so this Clippy thing is another way to get more people involved. And obviously if you're submitting a PR, reviewing a PR doesn't make you a first timer or whatever, but it might be that thing that makes you from a one-time contributor into a two-time contributor. And then once you've contributed to something, you fix a typo over here, but now you have to review this over here. Now you feel a little bit of like you have a little bit more ownership or a little bit more something like that. Like you're actually like part of the team now. You're not just a drive-by committer. So
yeah, I think there's a level of trust there that is just refreshing. compared to maybe some other projects where like you show up and if you're going to do this and you're going to commit to a review, like we trust you to do that work and tell us what you found, right? At whatever skill level you have. Cool. And I think that about wraps it up for us. We've been on for quite a bit at this point. Thanks, Pete. Thanks, Cameron.
What even is quite a bit when hanging out with you guys, though. So, you know, it's all good. Yeah. Oh, and shout out to Gus as well. Yes. Yeah.
So I think we'll see everybody watching this in about 6 weeks, hopefully for what, 1.98?
Yeah, 1.98 in about 6 weeks. And who knows what's going to be in that release? Maybe we'll fix a miscompilation bug.
Maybe. Yeah. All right. Cool. Yeah, it was good chatting.
Cool.
Cool.
All right.
I'll see you guys.
Yeah.